Okay, this next video is going to get you started on lesson 4.3. It's properties of logarithms. And the first thing we're going to do is change of base. Okay, let me explain to you why we have change of base first of all. If I gave you log base 2 of 4, you could tell me that the answer to that is 2 because 2 to the second is 4. Likewise, if I gave you log base 2 of 8 is 3, you could tell me that as a fact because 2 to the third is 8. What if I said, though, what's log base 2 of 5? So we know log base 2 of 4 is 2, log base 2 of 8 is 3, but how would we find log base 2 of 5? Now I know some of you have a calculator button that looks something like this, and it allows you to put in different bases other than base 10. But you need to demonstrate in this class that you know how to use this thing called change of base. And change of base is going to allow you to find these exponents that you can't just sort out by looking at the problem. For example, I know that 2 to some exponent is 5. I know that what goes in the box has to be between the numbers 2 and 3. Because 5 is a number between 4 and 8, so I know this exponent has to be between 2 and 3. So I could sit there and play with my calculator and do like 2 to the 2.1, 2 to the 2.2, 2 to the 2.3, and I could keep doing that and fine-tune it until I get close to 5. But there's an easier way, and the easier way is to use change of base. So log base 2 of 5, simply put, can be written as the log of 2. I'm sorry, I'm writing it backwards. The log of 5 over the log of 2. Remember, base will go in the basement. Or it's the natural log of 5 divided by the natural log of 2. So you can put either of those in your calculator. Log of 5 divided by log of 2, or use the natural log. And you're going to get 2.32. And I'm just kind of looking ahead here. Let's go ahead and round these to 3 decimal places. So x is about 2.322. So now if I take 2 and raise it to that power, I'll get really close to 5. In fact, let me see how close I get. 5.000. 24921. So I'm pretty darn close to 5. All right, this is your change of base formula written in this kind of table here. So basically it's showing you that you can use any base. What we typically have you guys use is either base 10 or base E. So I would write down the parts that are in pink. That's the most common change of base, or those are the 2 most common change of base formulas. So I'll make those nice and big for you. And then we have example 1 where you get to practice. So this is going to be the log or the natural log. You can decide which one you want. And remember, your base goes in the basement. That way you don't get it upside down. Is that the same answer I had up there? Yep. That's weird. I didn't anticipate giving you a problem that had the exact same answer. That's just bizarre. It's okay though. I mean, just do another one to show you that you don't get that for an answer every time. So log base 6 of 17 would be, I'm just going to do the ln this time. and that's going to be 1.581. Okay, so that's how you do those problems. Properties of logs. All right, we have some properties that you need to pay attention to, and you can read through this slide on your own. But these properties all need to be recorded in your notebook. So I'm going to give you some time to write down all of these properties. So get your heading down and let's clean this up a little bit. And write down your properties. All right. Once you've got them written down, you can see that right here, if I have a product, that's going to go to addition, but division goes to subtraction of 2 logs. This one, the power is just coming down to the front. I can do all the same properties with natural logs. Okay, we're going to work through example 2 and example 3, and then I'm going to stop the slideshow. All right. Write each log in terms of ln of 2 and ln of 3. So if ln of 2 and ln of 3 are the only tools I have in my toolbox, then this can be written as the ln of 2 times 3. That's the ln of 6. Let me rewrite this. I don't like how that's looking. So I replaced 6 with 2 times 3, and then using my properties, I'm going to take my product and split it up as the ln of 2 plus the ln of 3. For this one, since it's a quotient, I will split it up as subtraction. But when I look here, the only thing I can use are the ln of 2 and the ln of 3. Now I know that 27 is the ln, or I'm sorry, 27 is 3 to the third. And I know from the third property that I can bring my power to the front. And there you go. Problem solved. All right, find the exact value of each without using a calculator. Okay, so we're going to take this first one, and since it's a quotient, we're going to split it up into subtraction. All right, log base 6 of 1 is 0, minus log base 6 of 6 is 1, so that one's negative 1. On B, I have log base 2 of 8 to the 1/4. That's 1/4 log base 2 of 8. I should have switched colors. Equals 1/4 log base 2. And since my base is 2, I'm going to try to write 8 in terms of 2. So 2 to the third. And then this exponent of 3 is going to come out front. And multiply it by the 1/4. And that's going to be then log base 2 of 2 is 1, so 3/4 times 1. Okay, I can't take the log of anything negative, so this one does not exist. And that one's done. Okay, so just a recap before I do the last two. On A, I took the quotient and split it into subtraction. There are 2 properties I used. Log base B of 1 is 0, and that was a property from lesson 4.2, and log base B of B is 1. So those are the 2 properties I used on A. On B, I wrote it as a fractional exponent first. I brought it down to the front. And then I realized that my base is 2 and 8 can be written with 2's, so I took care of that. Wrote it as 2 to the third right here. And then that 3 goes to the front, multiplied by a fourth. Again, log base 2 of 2 is 1. So 3 fourths times 1 is 3/4. On C, what you're taking the logarithm of, x has to be positive. All right, let's try D. This addition means I'm going to go back to subtraction. Actually, I just said that all wrong. It means I can go back to multiplication, but there's actually an easier way on this one. On lesson 4.2, you learned that the ln of e to the x is x. So I can just apply that here. The ln of e squared is 2. The ln of e to the fifth is 5, and so that's got to be 7. If I want to use one of my new properties, then I would have the ln of e squared times e to the fifth. All right, that's because addition goes back to multiplication. I add my exponents, and then using that same property, I get 7. So you could actually do that one 2 different ways. Okay, last one. Subtraction. I'm going to squeeze it back together with some division. And I'm going to divide and get 25. And then I'm going to write 25 as 5 to the second. I can bring my 2 out front. Log base 5 of 5 is 1. 1 times 2 is 2. Or I could have taken this and said 5 to what power is 25, written it as an exponential, and I'd be right back there at 2. You've got some practice problems here that you can try, and there's plenty more on WebAssign. And then when I see you on Thursday, we're going to start here with example 4.